Okay, and we are live. So, first of all, thank you so much for all the attendees and people who have joined us in today's webinar. I appreciate your time on a Wednesday evening. My name is Shabd. I'm your co host, and I'm representing the organization IIDST, which is International Institute of Data Science and Technology. And we are here to attend a webinar on the topic Unlocking the Future, a Clear Roadmap to Data Science Mastery. So I am also equally excited, as I am sure that all of you are, because this is a topic which is, I guess, in everyone's mind. According to the hype that is there in the market, there is too many blogs are there, too many YouTube videos are there, too many institutions are there. So people who actually want to do the course are actually looking forward to something wherein they can get a clear roadmap of actually being where people are there already in the world of data science. So definitely we'll help you guys towards understanding the roadmap, and to get this better to you all, I have my speaker with me today, which is Sagrika Sachdeva Katuria. Hi, Sagrika.
Hi everyone.
It's an honor to have you on with us once again for this exciting session. So before I move further and talk to my learners and hand over the mic to you, I would just ask you to give a little introduction about yourself to the learners, so that they can know that who is the speaker that we have for tonight.
Of course.
Yeah.
So let me quickly introduce myself. Basically, I started my journey by doing my bachelor's. I did my bachelor's in IT and did my graduation in 2015. After that, for a couple of years, I worked as a software engineer, particularly a front end developer. So with that, it helped, of course, to understand the full stack, right? What backend is, what front end is, what middleware looks like, where you do the business logic. That is where it helped. And then post that, I went for my master's in Germany. I did my master's in mathematics and data science from Technical University of Munich. And after completing my master's, I started working full time with Siemens as a data scientist. Currently, in my role, I am working as a lead data scientist for a couple of products for Siemens, and then also supporting as a consultant for a ton of Gen AI projects and a lot of cool use cases we all see that are going on these days. Hope that helps.
Perfect, perfect. That's really good to hear about you. So, since all of the learners have joined and I can see people that are there, so before just handing over the mic to Sagrika to take you through the session of this roadmap to data science, I would just like to give a little introduction to all of you about the institution, that is IIDST, which stands for International Institute of Data Science and Technology, which is India's only premier platform for all the aspiring data scientists and web developers outside. So IIDST stands as a beacon of excellence, offering a transformative learning experience in this dynamic realms of data science and the web development areas. At IIDST, we understand the critical importance of staying ahead in the fast-paced world of technology. That is the reason our cutting-edge courses are meticulously crafted to provide a comprehensive understanding of the latest industry trends, and that is equipping learners with the skills necessary to thrive in competitive landscape. What sets us, that is IIDST, apart is its commitment to excellence, with a faculty that is compromising of and consisting of industry experts and practitioners who bring real world insights into the virtual classroom. Probably people like Sagrika and all the other trainers that we have, who are actually working as a data scientist and using these techniques as their bread and butter, and then they bring something to the virtual classroom which gives the students more understanding of current market scenario which is going on in this area of data science, or let it be the web development part. IDST also takes pride in its in our innovative pay after placement model, which ensures that students can invest in their education without the burden of high paying upfront cost involved. This revolutionary approach reflects the confidence that we as an institution carry in the quality of programs that we have, and underscores our dedication to student success. So whether you inspire to, let's say, unravel the mysteries of data science or master the intricacies of web development, you should give a thought about the IIDST program and the curriculum that we have articulated after our too much efforts and after taking help from all the industry veterans, that actually can take you towards the next step of your career advancement. However, we would obviously have the Q&As and everything by the end of this session. All of you have been put on a listen only mode so that you can listen to the speaker in a loud and clear manner and it can be more informative to you guys. However, there is a chat box option that is available on the right side of your screen, or if you have logged in from a laptop, you're going to see two options, which is one is chat, one is Q&A. You can either one, you can use anything to get and type in your questions, or you can be ready with a piece of pen and paper if you are having that handy, and you can type in whatever doubts you have. Towards this end of this session, dedicatedly we'll be taking the Q&As where all your technical aspects and all the questions related to this industry would be obviously answered by the experts. Sagrika, I would also intervene my opinions into that. Plus, anything related to the course or related to the program that you're going to have, I'll be taking it and helping you out to understand in all together with the concepts and the questions that you have, and assuring you that you take a bag full of learnings while you log out from this webinar. So thank you so much once again for your patience and time, guys. Over to you, Sagrika.
Thank you for the wonderful introduction.
Perfect.
Let me start. I'll share my screen. Let me know if you can see it.
Yeah, I'll just check that.
Yeah, this time we will check it.
Yeah, no worries.
See my screen.
Yeah, it is not visible yet. Something has popped up, but I guess the PPT is not available.
Just give me a second. Let me open the presentation over here. Yeah. Okay. Can you see?
No, I guess I am not able to see. I would also ask the learners if they are able to see, because
Let
I
me
guess I am.
bring and
Just stop the screen and then once again share it. No, I guess Rohit has responded. No, Mahima has responded. No, Dipakshi has responded. No. Okay, so no worries, guys. Let's just check that once again. So, Sagrika, you can just stop it and then once again share it.
Sure. See if this works.
I guess we are not still able to see this.
Let's give it a minute.
No worries. You just stop
The
it.
screenshot icon is yeah.
You can just stop the entire presentation. Then once again, you can share it with us. I guess there is some technical glitch in this.
Give me a minute. Okay, this icon is rotating.
No worries. You check for another 30 seconds, or else I'll just share it from my laptop if required. I already have the deck. If you want, I can share it.
Yeah, go for it. Go for it.
Just stop your screen share so that I can share, and I'll just make people look for that. Just give me a second. Apologize for the inconvenience, guys. Just allow us 2 more minutes. Let's sort this out, and then we'll begin with this session. Just 2 more minutes.
Check if you can share now. Perfect. Okay, perfect. Let me do that. Can you all see the screen? Can you all hear me?
I hope now the slide is meant. It's visible. I hope.
Mhm. I can see it.
Perfect. Perfect.
Okay, so let me get started. Hope my voice is clearly audible and everything is fine. If there's anything, feel free to write to us. Okay, so let's start with the topic. The topic for today we wanted to address in this webinar was mastering data science. It's easier said than done, right? There is a ton of stuff that goes around this topic. It's not just a fancy buzzword that we've been hearing for a couple of years now. When we talk about data science, of course, there are a ton of things that come around it, particularly when we talk about it. First thing is skills, right? What kind of skills do we need so that we are comfortable in working in the field at the end of the day, right? Besides the skills, couple of more things like tools. Right now, we have so many cloud technologies coming that it becomes really difficult for us to understand what are we supposed to use at the end of the day. Are all of them the same? Is there a difference between them? If yes, then for which use cases we should use what kind of tools? These kind of topics are very important for you to understand before we actually deep dive into key use cases and start using them at the end of the day. And last is strategies, right? What is the exact strategy that can help you to master these skills, to make sure that you understand the path of a data science project? What are the different aspects for it? Like, you need to collaborate with different types of people. You need to collaborate with business analysts, data analysts to gather requirements. You need to talk to your data scientists, get information from them, also from your subject matter experts who actually know about the data, right? At the end, subject matter experts can help you understand the data very much in detail, and that's what you need. Otherwise, we can just start working on any project, right? At the end of the day. But why is data science so fancy? Because you can apply it in any domain at the right. And like, you take space, you take defense, you take retail, you take education, healthcare, everywhere. What we want to do is improve the quality of decision making at the end of the day, and that's what we want to attain at the end of the day. So let's move on to the next slide. I want to deep dive into all of these aspects in a bit of depth, and if you have any questions, of course, feel free to write to us. Let's move to the next slide.
Just a second. Okay. Correct.
So, beginning from how do you want to build a strong foundation, right? When we just talk about introduction to data science, what are the foundational concepts that are important for you to know when you're trying to understand what goes around the topic, right? So first of all, when we talk about understanding the basics, machine learning algorithms these days, there are packages, libraries in the programming language you write, where you can just import them. You can call those functions, you can call those libraries, and just perform whatever you want. But at the back end, that function or that library, for example, if you import linear regression from scikit-learn, okay, it's a Python library. The linear regression is already implemented in some function, and you're just calling that function. So something is going in the back end, right? If you don't understand what happens in linear regression, how will you understand what your model is going to do at the end of it, right? First of all, when we talk about understanding the basics, we need to understand some concepts, and primarily you need to have some concepts clear which are related to statistics, probability, and linear algebra. Okay, what they do is, because when we try to understand these algorithms, these concepts are all around it, right? When we talk about linear regression, when you talk about accuracy, you want to minimize your error, all these topics have some formulas going on behind the screen. So when you try to go and understand that concepts in the back end, it should not be a black box for you, right? There are some core concepts for statistics that you need to understand, like what is a mean, right? What is standard deviation? What is a mode? How do you apply it? So these basic concepts should be clear, and then of course you can start to understand your models, and it should be a free flow. Nobody wants to go and deep dive into like a lot of math background, but you should know, at least when somebody is talking about using a mode to fill some values, what does it mean, right? What does it mean to maximize the probability? These topics. That's why you need to understand some of these topics in detail. It's very important. Second step is learning data manipulation. Another term for this is data engineering also. So this is actually another role in which people are working these days. And why do we actually need this role? This role is so important because as a job of a data scientist, almost 50% of your time you will be working with data manipulation. Why? Because the source of your data is at some place, right? You get the data from that source. Now, before actually applying your machine learning, you want to tweak it, transform it in some way so that your machine learning models actually understand it. This is the step where your subject matter experts pitch in, where they tell you that, hey, for example, if you're getting missing values in the data, right? If you don't talk to your subject matter expert, you will just fill those missing values with, for example, averages. And maybe that's not the right approach, right? So data cleaning, data transformation is very important. And exploratory data analysis is a process where you just do some charts, graphs, analyze your data as it is, just to understand, okay, how your data is behaving, how some columns are behaving, which columns are more important than others. So this step is again very crucial, and ideally this takes a ton of time also in any data science project. Third step is of course developing programming skills, right? You need to know either Python or R. Primarily Python is very proficient in generic use cases, right? R is more important when you have projects where there's a lot of statistics going on. In those cases, R is very good. But a lot of times people do end up using Python because of the comfort and ease of use. It's more close to how your JavaScript works or your other programming languages work. That's why it's more comfortable for us. Again, with programming skills, Python, again, it works when your data size is, not that big. That is where some additional concepts like big data come in, because Python, it's very difficult to handle big data in Python. This is the reality today. If you have millions of transactions, for example, if you have millions of records in Python, it will take you a lot of time. So, but that's where we have some advanced data science as well. Just to get started as a base, if you know Python or R, you are good enough. Whatever you can do in Python, you can try to do it in R as well, right? And once you know Python well, then you know where are your problems. Then you can learn other technologies like Spark and all, which are good for big data or other use cases. And the last part is practicing data visualization. It is very important, not just for your analysis, but also for showing your results to others, right? And this is going to be the key for you. At the end, whatever work you do, if you don't present it nicely, doesn't matter, right? Your managers or the people you're working with, they need to be able to see the key insights that you get, the basic analysis you do. You can always use this for validation also with your customer, that, hey, your data looks normally distributed, or your data has a lot of weird values. Why is this happening? So in those cases, data visualization helps actually from the starting phase to the end phase. Also in the end phase, because you have to show your output somewhere, right? So when you do it in your programming language like Python, of course, you can show your results for a POC, for example, using that. But when you're trying to deploy your applications, you need to know Tableau or Power BI, either of these softwares that we have for data visualizations. They're pretty easy to use, easy to understand. It's a software, so it's drag and drop based, right? It is pretty easy to do visualization in that. And the key will also be to understand what you are drawing up, right? Analysis is also very important, that what insights are you getting from this data. Hope this helps you understand why the strong foundation and these topics are needed before you actually start working on complex use cases. Move to the next slide. Now, coming to specific focus on machine learning, there are different types of algorithms that exist. Okay, and totally it depends upon the type of data you have. So let's start with the first one. I'm going to introduce all of these briefly with you, just so that you know which kind of use cases belong to which kind of category of machine learning algorithms here. The first type of machine learning is supervised learning. And what supervised learning means is, imagine you have a data set. Okay, you have your banking data set where a bank is going to forecast for you if you are going to get a loan or not. Okay, for example, or they want to forecast for you that, okay, in next 6 months, how much money will you use from your account? Just a simple use case. In these kind of use cases where they already have your actual values, right? They have the data already with them. Like in past 2 years, they already know how much you have spent. So in those cases, when you have the value that you want to predict in your data set, right? That is where it's called supervised learning. You have labeled data, right? You have something to test your results with. If I want to forecast my spendings for next 6 months, I can train my model for 1 year of data, then test it on next 6 months, right? Because I have the actual values for last 6 months. So I can do a prediction, I can test it, how good it is, and then I can do a forecast. I have something to test my results with. That's the supervised learning use case. And some common supervised learning algorithms are linear regression, okay, multiple linear regression. You have tree-based algorithms like decision trees, XGBoost, which are a bit of complex algorithms, but really good to use, really good. Like XGBoost is one of the finest prediction algorithms when you have good quality of data and good size of data. Okay, if you have like just hundreds of rows, that won't, then you can't use some complex algorithms. In those cases, you can fall back to simple algorithms like linear regression. So, and also like till date, whenever we are doing these use cases, we try to see which is the simplest use case, which is the simplest model we can use. We don't want to complicate it, right? You use the simplest model, you get some benchmark results, and then you work on top of that to improve. Okay. Moving on to the second algorithm that we have, second type of algorithms that we have are related to unsupervised learning. In unsupervised learning, what we are trying to say here is that we don't have an output variable. Okay, our data is unlabeled. We don't have any output variable. We want to get or extract patterns from it at the end of the day. So unsupervised learning, some algorithms, for example, is clustering. Right, you have some data for some customers like Amazon, right? You have some purchasing patterns, like I try to buy some kind of stuff, some others will try to buy some other kind of stuff. But in general, when a model has to do some recommendations, right, it does not have any Y label or any output. It will try to see, okay, what you have done, and it will try to suggest some other values to you. There is no way to check it out here, like what it did. So in unsupervised cases, usually you don't have an output. You try to generate or classify that output into some categories. Logistic regression is another fine example for unsupervised learning, where you have outputs with either 0 or 1 values, or true or false. That falls into unsupervised learning as well. Okay. Next one is deep learning. Deep learning is used in case of complex models. Again, another thing for deep learning is you need to have good quality of data, good size of data. If the data is very less, then again fall back to simple algorithms. Your deep learning models will not work well. So deep learning we use in a lot of use cases. Like even we have some deep learning models like LSTMs, RNNs. I'm not sure if you've heard of it. So some of these models you can also use for prediction if you have good quality of data again. But otherwise, deep learning is used in a lot of computer vision use cases where you have a lot of image-based data. You store that image-based data in the form of bits, and then that data is sent to the models where it preprocesses. So where you have some complex models going on, where you feel that, okay, deep learning will help, in those cases, we can apply deep learning models. Primarily, the thing is, it's not easy to understand the data. In those cases, you apply deep learning, and the size is also very good. Specifically for image recognition, it's used in a bunch of use cases. Last but not the least, AI integration. Now, when we talk about AI integration, like the classic thing that comes to our mind are chatbots, right? Gen AI, LLMs, all these cases where what we're trying to say is that, hey, we've done machine learning, we've got some predictions, we've got some insights on the data already, but now we want to show it to the customer in a meaningful way, right? In those cases, you want to improve your existing results in some way, right? For example, you have done some prediction. Now you want to show the customer that, hey, if this is your prediction, this is the impact you will have. In those cases, you want to integrate some chatbots, right? You want to do some LLM, train it to explain to the customer what are the insights they're able to get from your dashboard. Now, with our machine learning use cases, on top of that, we are integrating AI. So to post-process the results and make sure that we are providing quality results to the customer. A typical use case for Gen AI, reinforcement learning, all these use cases is, for example, textual data, survey-based data, where you have comments coming in. You have textual data, right? You send those comments to Gen AI, ask it to find some topics. Where do you have more negative comments? Where do you have more positive comments? So there are a bunch of use cases. Textual data is everywhere, right? So in each and every use case, you can find some Gen AI implementation. Let's move to the next slide. All right. Now let's talk about some cool tools and technologies that we have been using in data science. Okay. Like I said, Python and R are like most common programming languages. Python more than R. Today, at least what I've seen in generic use cases, Python is the most common programming language that people are using for data science. And it offers you a lot of pre-built libraries already, and you can just import those packages in your code and start using those functions. So Python is pretty easy to work with as well. You can find a lot of platforms as well where you can practice Python too. Second most important is SQL. So Python is important because, you imagine you have your data in the form of a CSV, or you have data in a particular database, right? You will load that data, you can start working in Python on top of that. But why do you need SQL? You need SQL because a lot of times your data is stored in databases. And before actually getting the data, you might have to test, right? Different queries on different tables. Before actually starting coding in Python, you might want to try, see if join query to get the data is working fine or not, right? If the data you're getting makes sense or not. Even for validation purposes, a lot of times you might have to go into databases and try to explore or do some root cause analysis with it. That's why you need to know SQL. It's like a must need. It's a need at the end of the day, right? Because anywhere we talk about data, databases do come in, and we know databases use SQL or some kind of wrapper around SQL always. So if you know one, you can use others as well. And third one, cloud platforms. We are going to go into a bit more detail also for this topic, but cloud platforms specifically, when we talk about cloud platforms, we have platforms like AWS. Okay, we have platforms like Azure by Microsoft. Then we have Google Cloud Platform from Google. We have Databricks from Microsoft again. We have, of course, Snowflake as well. And all these cloud platforms are now offering you a space to do your machine learning. Okay, but they are different in their own ways. Okay? For example, I want to talk a bit in more detail on this topic for cloud platforms. So when we talk about AWS, how AWS is set up is it stands for Amazon Web Services, right? So the last word, services. What they're offering is they're offering a lot of services. What they do is, if you want to store data, we are giving you a service called S3. So S3 is like kind of your database where you kind of store, or a folder file system, like we have our file system in C drive, D drive, right? It's like that, your S3, where you kind of want to just store data. Then if you want to do machine learning, you have SageMaker. If you want to automate your pipelines, you have some different services like Lambda and Glue. So for each task, there is a different service. So essentially, AWS, now you have SageMaker Studio as well. But with SageMaker, do you understand? Like when you have these different services and when you want to automate, you need to make sure all of them are connecting. So automation in data science is kind of a hassle in AWS right now. But of course, it's doable. And if you have simple use cases, it's absolutely, people are using AWS heavily for machine learning and operations as well. Same applies with Azure. Azure will have some blob storage. The storage type, the name is different, right? But you have a storage. Okay. Similarly for Snowflake, Snowflake is itself a storage option. But then now Snowflake also offers Snowpark, where you can do your data science. Again, one of the most famous, and also like I am a fan of it, it's Databricks. Like, not promoting like that, but like I like it because of the ease of automation. So it's like, of course, you can code like your Jupyter notebooks, but Databricks is specifically important when you have big data projects. Okay, it helps you over there, and there you can automate your pipelines using drag and drop. So you can have 4 scripts, right? You can just drag one script after the other, and it will create the pipeline for you. You don't have to do any automation on your own. It will do it for you. So for a lot of big data projects, Databricks is like very easy to use, easy to code, especially with big data. You want to see your results in between, and it behaves like a Jupyter notebook for you. So it's pretty cool like that. So with cloud platforms, now we have so many options. Again, depending on your use case, right? If you have simple use cases, do it in AWS, in Azure, Google Cloud. But do try to understand when it comes to automation, going live, when you have to run your pipelines daily or monthly, depending on your requirements, what platform works the best for you. That's why it's important. Another one is Jupyter Notebooks. We are all, I think, we all have somehow heard of it, used it. It's like the simplest way to get started, right? Download Anaconda on your laptop and you can have Jupyter Notebooks up and running. And the simplicity of Jupyter Notebooks is, if you want to do nothing fancy, right? If you just simply want to explore the data set, and it's nothing that you're doing for yourself at the end of the day, some personal work also, Jupyter Notebook is very quick and easy to get started with. So before, actually, if you have not tried anything, before going to any cloud platforms, try out Jupyter Notebooks, test your data, even just load the data, try some data cleaning operation and stuff like that in your Jupyter Notebooks. Because wherever you go, if you go to AWS on SageMaker, you will get a Jupyter Notebook kind of environment. If you go to Databricks, you will get the same kind of environment. So it's like pretty much the same. If you do it once, you can do it anywhere. It's just some things will change, but yeah, the base stays the same. All right. Moving on to the next slide. And just on the last slide, like this, these are just a few that I wanted to point out on. And like there are more tools and technologies like for data visualization. Yeah, we have Jupyter Notebook is for your internal programming, but like you can go to Tableau, Power BI. You can there, because it's drag and drop based, right? So again, if you do it right in Jupyter Notebooks, if you can do your visualization using Python, then when you go to Tableau or Power BI, you will be like, oh, I can do this, that kind of a thing, right? So you have data visualization platforms, and there is a lot with regard to machine learning operations that's going on. But basics, when we talk about essentials, if you know Python, if you can code in Python, and if you understand any one cloud platform, you are good to get started. Okay? All right. Let's go to the next slide. Yeah. All right. So we've discussed a lot. Now I want to discuss some different fields that we have. Okay, so basically we have, for example, real world applications for data science across so many industries, right? So first of all, just to get started with, we are going to talk about different domains. So first one is healthcare. So in healthcare, what we see is with, of course, data science applications, you can revolutionize the industry in a lot of ways. Some examples we are going to talk about, like, first of all, you can suggest some personalized treatment plan to a customer, right? If you have their historical data, you've seen, okay, what works for them, what doesn't work for them, we can use machine learning to do some recommendations for the customer. A simple basic use case. Another very cool use case that's coming these days is drug discovery. So with GenAI specifically, you can, simulate a lot of drugs as well. You can tell the GenAI model that, hey, these are my ingredients. This is what I want to achieve. Suggest me if I can do it or not. Just a simple use case. As long as you have some ground knowledge, you have good quality of data, you can generate a ton of healthcare based use cases. Medical imaging, it's getting used so much, like cancer detection. We've seen so many use cases in healthcare. So it's transforming so many industries. I just wanted to state a few here. Second one is finance. So with finance, we have seen, like, specifically when we talk about use cases like, forecasting and predictions, they mostly apply in financial use cases, right? Because you have some kind of money going out on a daily basis in a ton of directions wherever you go, right? You go to retail, you go to manufacturing, you go to big companies, there is financial data, so much of it as well. Some common use cases, for example, could be anomaly detection, right? Millions of transactions are happening every day. Some could be manual too, and there could be a lot of human errors, or automated stuff can also happen. And if you have so many records on the basis of millions, how will you try to analyze what went wrong when, right? It's difficult to analyze. That is where machine learning helps. You can use anomalies to filter out some transactions that look weird. You can ask the financial people around you to, hey, check it out. Does it look weird to you? And if you're doing this on a monthly basis, it's easy to do. You might find some 50 of cases which you can go and check. But if you don't do it at all, a year later, you go and realize, oh my God, something weird happened and nobody saw it, and now it's too late, right? So where it helps you is also decision making and enhance your quality of work, right? At the end of the day, you can make risk management better also. So hopefully financial forecasting, anomaly detection, these are pretty much common in finance-based use cases also. Another cool use case in finance is scenario analysis. People are talking about scenario analysis. It's actually based on a technology called digital twin. I'm not sure if you guys have heard of it, but what we want to do, and even we have customers in Siemens asking us to do that for them. In fact, India itself. So what they want to do is they want to see that, okay, 2 years down the line, inflation of India is this much. Now, how will it impact my numbers? So you do some simulations where you do, okay, what if this happens? Then how will it impact my numbers at the end of it? So a lot of cool use cases in all of those domains. Actually, we can talk on and on about it. But okay, let's move to the next one, which is retail. And retail, I think all of us are very close to retail because we all are so much into shopping. We are all online already, like Amazon, Myntra. We have so many platforms to shop on, and you must have seen it. In fact, you must have seen it on your social media also, recommendations systems, how they are working. Go search some product on Google and you see recommendations in your Instagram, right? So this is how it's working on. They have tried to personalize, they've tried to recommend you stuff. They want to increase your purchasing patterns by suggesting you what you like. This is all being done using data science and trying to understand. So for example, recommendation systems is again an unsupervised learning use case, right? Where you don't know, but you want to recommend something. So it overall helps in boosting their sales, increasing their numbers, and overall improve the quality of a customer journey, right? You don't want to see stuff that you don't want to buy. So exactly. Yeah, hopefully this helps you in understanding the applications of data science use cases in real world. These are just few areas that we've seen, few industries, but sky is the limit right now. If you get bored from one, you can go to another. Yeah. Okay, let's move to the next one. Okay. Talking about career growth and success, right, in data science. First and foremost, very essential to build a strong portfolio, right? If you are doing some personal projects, create a Git repo, upload it on Git, right? If you're trying some Kaggle notebooks, publish your results in Kaggle. You have, again, it will be a Jupyter notebook kind of a structure. So also, whatever you're learning, whatever you learn today, if you're not posting every day, but like you should be kind of posting it occasionally on LinkedIn or whatever social media platforms you do use. So what it helps is, it also helps your exposure, A. And second, what you're learning today, you are just creating a post. And we all know today it doesn't take more than like 5 minutes to create a post. You've learned that you can just use ChatGPT to create it for you. Try to include all these GenAI tools. I'm sure, I hope you all are using it to improve your productivity, right? Smart work than hard work. That's what we should aim for. So for a strong portfolio, like we said, you need to understand Python. You need to understand machine learning algorithms, what they are doing, which use cases get applied to which kind of algorithm, right? And if you are able to talk about your journey in project, people can easily identify if you've worked or not, right? Because if you've actually spent time on a project, you understand the issues you faced. You understand issues you faced in every part during requirements gathering. You can talk that, hey, the customer shared these details with me, and then I did this work, but then they left out some stuff. So of course the results are not that good. But if you've not talked to the customer or to your subject matter expert, you cannot justify everything. You need to be making sure you have all the requirements cleared, right? After your requirements clarification, you need to have good skills in data engineering, data cleaning. After your data is clean, you need to understand what are the important columns for you that you have to use. After that, to generate your results, you have to know what are the metrics you can share with your customer. You can share some error cases, error metrics for predictions, or you can share accuracy for your classification kind of problems, yes or no kind of problems. So you need to be able to talk about it and expose yourself. Even if you are exposing yourself on Git and posting some stuff on LinkedIn, you should be good enough. Consistency is the key at the end of the day. Okay? Second most important thing is networking and collaborating. Of course, if at your workplace you're collaborating all the time, but collaboration externally is also important, right? Two ways to, of course, do it. There are so many external conferences that are happening, which are free of cost. Okay? Wherever you are living, like Mumbai, Delhi, at least all the main places, a lot of cool conferences are happening, and most of them are virtual. So make sure you take part in them, and make sure you ask a few questions, or you at least get to know some people, right? Also, when you network on LinkedIn, you make sure you introduce yourself, and it's just good. It's just respectful when you try to just introduce yourself when you are, sending a request on LinkedIn. And what you can additionally do is, whenever we collaborate or when you're on LinkedIn, right, instead of asking some direct questions for which you'll find the answer on Google or wherever, try to ask some specific questions for that person. Go check out their profile, go see what they've done on and what interests you, and then pick some questions from there, right? And then ask them. It'll help some broaden your mind. Also, just learn something new from somebody, and just you just stay in touch. And you don't know, when networking is so important, like in India, also, and even abroad. Like if you don't network people, it's really difficult to find a job too. So it helps there as well. Okay, be mindful of that. Third one is continuous learning, and can't stress enough on this continuous learning aspect, because every day something new is happening. So many technologies, every other day we see a new GPT model coming out, and how do you know which one to use? How do you know which one has more costs or less costs? If you're not updating yourself, at the end of the day, it's about how much you are able to focus on new kind of scenarios, new situations. What is your problem solving? So that can help when you kind of stay updated. You don't have to do anything. You have to follow a few of the newsletters on LinkedIn. Now there's so many newsletters. Follow a couple of people who you actually like and read their newsletters. You'll get an email for it, maybe one or two, and they will actually provide you some key insights in data science field already. Just go through it, maybe repost that stuff on LinkedIn, and that's your continuous learning, right? Besides that, Coursera, so many platforms where you can just go and learn new skills at the end of the day. So that's up to you. But if you want to stay in data science with the way we are proceeding, you need to at least know how things work. If not, you are working on it, at least you need to know how they are working, right? How do you apply GenAI in a project? How will the ML flow look like? What will your pipeline look like? These kind of ideas you should have. Okay? And then last but not the least, soft skills. Again, can't stress enough of it, right? If you want to make an impact, right? This is the field to grow in, right? If you have a strong portfolio and if you are able to present your results well, And if the quality of results, they could be bad, like initially, right? But if you are consistently performing, you should be able to, kind of expose yourself, talk to your managers, showcase the work you're doing in presentations, ask a lot of questions, and specifically when we are doing customer demos, focus on to the point. Okay, focus on the flow you followed. Each slide should be strategic, and of course the presentation is also very important. This is where you actually show yourself, right? We kind of, even in, like, it's not everywhere. Even in my workplace, I've seen some people don't say anything at all, especially when you're working virtually. So if you're not going to office, it kind of becomes a bottleneck because you kind of stay in your silo. Of course, if you're going to work, that's amazing. But kind of your meetings where you have a lot of people is the place where you show yourself. Ask question. If there's nothing, just ask any question. Okay. And whenever you're presenting your results, make sure you have all the specific answers and you have the clarity of the thing, and be confident and go for it. Okay. Hope this helps. Let's move to the next slide. This was a curious thing I wanted to add here. Some hidden facts or unknown facts about data science. Like, these problems happen all the time, right? Whatever use case you see, this can occur anytime, and it becomes redundant, and then you have to see, okay, how do I address this? So let's talk about it. First one is the curse of dimensionality. Okay, so suppose you're getting a data where you have like 200 columns, getting a data set with 200 columns. Now you want to do machine learning on top of that. The model, how will it understand which column is more important than others, right? So this is the case where your dimensions, which is the number of your columns, that becomes a curse. What do you want to do here? You want to address this problem, right? You want to bring your 200 dimensions to just 2 or 3, which contain the most important information. So we can address this problem. There are algorithms like PCA, okay, principal component analysis. That's like one of the most famous algorithms we use to address this problem, where we try to reduce the number of dimensions. Okay. Second one is the no free lunch theorem. Okay. What this means is, okay, you're creating an algorithm for one use case, right? You can't be sure that it works on another use case. What we're trying to say here is there is no one algorithm in the world that will work for all your use cases. Each use case needs a different algorithm depending upon the use case. You need to try different things. You can't assume that there is one algorithm that works for all your models. No, that's not the case. It also depends on it always depends on your use case. So this thing that one size fits all, it doesn't work here. Your one algorithm, for example, XGBoost, will work good in big size of data, but will fail miserably if the size of the data is less. Basic examples. Okay. The third one here is reproducibility crisis. What is reproducibility, right? You've produced something. Now you want to produce this again. Same thing, right? So what happens? Like today, I'm using my models to train some stuff. It's giving me 95% accuracy. Next year, same models are giving me 85%. I can't reproduce my results. Okay. What it means is you need to improve your models. Okay, at the end of the day. So when we're talking about reproducibility, there are more topics that then come than we think. So because a year later, you won't know what you coded 1 year before. So if you have good documentation, if you've written your code in a good systematic way, and it's linked to some repository in Git where you can go and see what kind of experiments you did a year back and now what you need to work to improve it on. So for that, documentation, version control using Git, and basically if these resources are available, it becomes easier for you to identify what went wrong and then improve it. These are some hidden things that always go behind the data, and we always have to be mindful that we know these topics, and this doesn't happen with us at the end of the day, right? Okay, next slide. Again, one of the most important topics these days. Also, ethical considerations when we talk about data science, right? This topic is so sensitive these days because it's becoming close to all of us, right? We are seeing deep fakes everywhere. We are seeing scams happening everywhere to the closest people, to friends, and ethical considerations with regard to data and having good data laws is really a very important matter of fact for all governments right now. They are working in that direction, and of course we'll get there. But on an individual level, what can we tackle, right? That's more important for us right now. So first issue ethically that happens is bias. Your bias in data. When I talk about filling in missing values, right? We can use averages to fill in missing values. It's a bias you're adding that mostly averages work. So let me just fill in my column where we need to fill missing values with averages. No, you need to go check with the subject matter expert. Does it even make sense to fill it with averages, right? Bias comes in, and bias has been a very important factor when we are developing algorithms, right? If you're creating some algorithms regarding hiring, HR based algorithms, right? And if your data has, like, just saying, for example, if you have 60% population between 30 to 40 age, 60%, that becomes a dominant factor. When you do your forecast, you will see that almost 60% of your predictions will also have that same age group of people. Why? Because the data is actually dominant with one type of data set. So we need to be mindful, where do we see bias? Does the bias make sense? If the data is imbalanced, how do you make it balance? These kind of questions, they come up when you're doing data engineering or data gathering, data understanding. This is where these kind of topics come in. Okay. Second one is data privacy. Now, data privacy, especially the simplest use case is Gen AI. Siemens, like I'm working with Siemens, you might be working with any company. You can't send your confidential Siemens related data and go and use it on ChatGPT, ask it to give you some suggestions. Ethically, it's not right for me or anybody who does it. Siemens has given me a co-pilot which is internal to Siemens. I can do it over there, but I cannot take internal company data to external and then try to see if I can. That's not right. And data privacy topics are also coming because in the data you're feeding to all these systems, there are person names, there are mobile numbers, email IDs, personal information. It should always be encrypted if you're sending it to somebody outside your project. You should mark your mails as confidential, take care of these kind of topics whenever you're sending data in your emails or giving access to somebody who ideally shouldn't have access to. One is transparency. Okay. Transparency is a very big topic, of course, because machine learning models, like I said, it will be a black box for your customer. They don't know what fancy stuff you're doing with your models, and you're coming with that result. So explainable AI is a very big topic these days. I'll give you an example of explainable AI. With anomaly detection, for example, the use case of anomaly detection, you don't have any labeled data. Okay, assume you don't have any output. You have a transaction and you have to tell if this is an anomaly or not. You don't have any yes or no as output already. Okay, so now in this kind of data, where you have anomalies, yes and no is enough. Okay, for the customer, you can also just show them that, hey, these are the 10 anomalies that I found. But what if they ask you, why are these an anomaly? What made you think that this transaction is an anomaly? You should be able to point to a particular column, right? It could be amount, that the amount is very huge, right? But you should be able to explain why this is an anomaly. This is where explainable AI come in. Now, your model results are not enough. You need to be able to explain to the customer, right, what happened and why it happened. So in anomaly detection, we have a library called SHAP. If you go search for it, SHAP, for example, it gives you the features, top 5 features or whatever you request, which actually suggest that, hey, this is why this transaction is anomaly. By features, I mean columns. It will give you exact column names which are pointing towards anomaly. So transparency and these topics, even if like right now you don't think about it, but now literally data science use cases are getting audited in each company and you have to document all of this. So you need to prove to them that you are following all of this. And exactly, last one is the same, accountability. you need to make sure, right, that if you are taking a topic, you're accountable for it. Your managers, like 2 years down the line, if you worked on a topic, it doesn't go away if it's still running, right? You will be held accountable if you did not do something right 2 years back for your results, because sometimes these results can have a long lasting impact too, especially if there is bias, these kind of factors, right? Sometimes things can come up which you cannot justify. So you need to make sure you document at every level all your results, experiments, metrics. It should be documented. So later down the road, you have something to justify. Okay. Right. Let's move to the next slide. Also, this is the last one. Yeah. Future trends. Okay. What are we expecting in the future with data science? Of course, data science is no more limited to dashboards, right? Especially with Gen AI, LLMs coming in, there are huge topics getting addressed. How we are going to evolve data science now. So first, few examples I've mentioned here. First one is quantum computing. Okay. Basically, in quantum computing, a classic example of quantum computing could be security, but also like we just talked about drug discovery, right? So whenever you have very complex use cases, you need huge GPUs because you have a lot of data to train with, okay? And a lot of parallelization that needs to happen. So it cannot happen on our laptops. So when we talk about complex topics like these, we need to involve quantum computing in it, because what it does is it helps in your data processing. It's faster. It makes it faster. So what it means for the future, in future, we'll see more use cases coming out of quantum computing. We might have to use quantum computers to perform a lot of use cases. One is augmented analytics. Have you all seen Iron Man? How he flashes the screen in the air and then he manipulates it? That's what augmented analytics is, right? Where you can play around with your BI tools, right? You can play around with your BI tools and you get insights there and then. So that's very cool. You get it from your watch, get it from your robots, augmented analytics, where they can have a screen in the air and they can analyze things. So this is going to happen. And the last one is Edge AI and federated learning. These topics are around our IoT devices. So like your smartphones, Alexa at your home, your iPads, like all of these devices are going to have AI in it, inbuilt to it. So you're going to see all the devices are so close to AI now, which was unimaginable before, right? All your devices are AI empowered. So that's what it means. I mean, these topics, and there are so many trends in data science because it's always evolving. But yeah, feel free to explore more use cases, and there is so much around this topic. But for now, this is what I essentially wanted to share with you, give you a brief in nutshell what data science is all about and what are the predictive or future trends we can see coming out in the next few years for us. Okay. Thank you so much, guys.
Well, thank you so much, Sagrika. It was such a learning experience. I hope all of my learners also will be taking something new in the bag of learnings tonight. So let's not make them wait. Let's just start with the questions because I can see there were multiple questions that were asked. So I'm going to pick the questions that were previously asked. And in the meanwhile, those who are attending live with us, you can still type in your question in the chat box and I'll be taking those questions one by one. Okay, let's go ahead with the questions. Cool. The very first question I have is from Rajesh Reddy. That what are the key differences between data science, ML, and AI, and why is it so that in India every next institution or everyone's is promoting to learn all these three techniques together if you want to enter this world? So it is a very nice question. So
No,
yeah,
it's actually a very nice question.
yeah,
So data science, it, in general, it consists of everything, right? Because it's not specific to any one use case. But when you talk about machine learning and AI is actually a subset of machine learning. Okay. So when you talk about what is the main thing, that's machine learning. Within machine learning, we saw 4 types of machine learning, right? That your unsupervised, supervised, your Gen AI is also coming within machine learning. So it's a subset of machine learning. Okay. at the end of the day. So when you talk about machine learning and AI, actually you're just talking about machine learning. It's that machine, after you do machine learning, you
Right.
also want to improve it by doing some additional stuff.
Mm.
So with AI, specific to AI, right?
Mm.
Let's just focus on AI related topics. So reinforcement learning is AI. For example, you have results from your machine learning, but now you don't know if they are good or bad. With reinforcement learning, which is AI, you can penalize your bad results, reward your good results, have a system which learns and adapts, and that's where you get an AI with any. Okay. So don't confuse these topics. It's all a part of machine learning. Everything is a subject of machine learning. Okay. Hope that helps.
I hope, Rajesh, you're satisfied with the answers. So, if not, then also you can go ahead and tell us in the chat box. We'll try to resolve it. In the meanwhile, I'll just move to the next question by Minakshi. That how has the role of generative AI like Chat GPT, etc., evolved in this field of data science in 2024? How can we see the differentiation of AI from 2019 or 20 and then in 2024 in particularly sector of this data science?
Mhm. So around 2018 or 19, you must have heard companies moving to cloud. This happened from 2018 actually.
Yeah.
Until then, cloud was also new, if you remember, right? So in these past 3 years, what companies have done, they have set up their data platforms. They have connected their data source resources. They have purchased licenses with cloud providers, service providers like AWS, and now all of them have their own cloud technologies. Okay, this is what happened in the past 2 years at least. From last year with GenAI, what happened was data science use cases were happening, but they were not happening with that scale. When GenAI came, now everybody wants data science. They want something wow, although they don't understand what wow is, but they want it. But what are
Right.
you doing with GenAI at the end of the day? Like I said, you do your machine learning, you get some results. Let's take the example of survey data I was talking about. You can take your comments data with your natural language existing models. You can use BERT topic, you can use Roberta for sentiment analysis. They will give you results. But what GenAI will do for you? If you do topic modeling with BERT, it will give you 10, 15 most occurring words. It will not give you an intuitive answer, right? So in post processing, you can use GenAI to tell them, hey, this is a topic that got created. These are the comments for this topic. But now I'm sending my comments again so that I get a nice topic name using GenAI, right? So with GenAI, what we are trying to do is we are trying to improve customer engagement at the end of the day so that they can understand the results in the simplest way possible. They can ask the system what they want to know instead of us trying to explain to them, hey, why this happened. So again, explainable AI, that's what happens here, right? With chatbots and everything, and also automation, right? For a lot of tasks, there were people manually doing a bunch of stuff. Now with GenAI, it helps in, of course, automating also a lot of simple tasks because it's textual data. You can ask it whatever questions you want. You can ask it to summarize data. You can ask it to rephrase text. So all these are getting included in whatever use cases these days. So whatever use cases we had for data science, now customers are asking, hey, Tableau is not enough. We need a chatbot to explain.
Right.
So they move to Power BI because Power BI has a chatbot. So that is what is happening.
Great, great. I hope, Meenakshi, you have an answer to your question. Now, I'll take the next question from Pratyush. That what are ethical concerns surrounding AI and machine learning in 2024, particularly in areas like data privacy and bias?
Yeah. The example of bias is the Cambridge Analytica hack that happened 3 years back in US elections. Their elections were turned over because of bias. Okay. What they did, they targeted people for promotional marketing email. Okay. And they bombarded them with that, which the other party did not do. You by
Correct.
default included bias in their minds by changing the way you are approaching the problem. It could be smart work. They won the elections, right? At the end of the day. But you included bias. Similarly, bias can be included, like I said, if your data is dominant to a particular category, your predictions will also be dominant to that category and it will show, right? So if your training data is imbalanced for a particular category, then of course there's bias in that data. And in actual, if the reality is that, okay, your, for example, the bias part here is like, if you're 40%, the age group example I was giving, 40%, 60% people in 30 to 40 age, right? If that's the reality, it's fine. But if your data set is low and one category is biasing, then that's not correct. So that's where bias comes in. You need to make sure each column of your data does not include any bias. Okay, it is normally distributed. That's the correct value. The distribution is normal. And second one, what you said, what was that after bias? One more topic that he mentioned.
Privacy.
Okay, data privacy again.
Yeah.
Classic example with GenAI, right? If you are sending your customer specific or company data to ChatGPT, then you are leaking personal information, private information of a company, and your LLM will take it, use it for training. ChatGPT, we don't know how OpenAI is training yet, right? They might have used laws, but they kind of get a consent from you every time that, hey, we are going to use this information for training. Hope you know that. So privacy is so risky these days, especially because all your use cases, you have to make sure whenever you share your models, you are sharing with the right set of people, right? When you're sharing your data, you mark it as confidential in your emails. Be mindful of these kind of topics. Data leakage is so common these days. People are in fact selling data for a month, for a price. It's that bad. Right?
Correct. I hope that answer your queries. I have a question from Bhavesh. ML is subset of AI or AI is subset of ML? Very nice.
let's check it on Google. Actually, this, as far as I actually attended a conference couple of months back, and same question came up, and that is where we kind of sorted it out that, hey, machine learning is kind of the whole set and AI is a subset. But let me check. could be wrong. Okay. Although I feel, as far as I've understood it, okay, like if we try to get and check some images, what you can understand is that overall there is this huge network. Let me confirm this.
See, it's a kind of question which is very much in the mindset of people who are in this domain, because AI and ML are very closely related, but also not the same as
No,
we categorize. So
no.
ML is one of the subsets, but obviously consumer or business can, I think consumer and business both can be benefited with the use of AI and ML together,
Exactly.
which can lead to increased ROI or probably improved customers satisfaction or business decisions. So the end user can expect more personalized and human oriented probably services and decisions.
Exactly. Like when you talk about AI in general, maybe you can keep it as a whole set. But when you're talking about reinforcement learning, Gen AI, this is all integral to ML. This is a subset of ML. You can call it overall AI, but all your deep learning models, all your transfer learning, reinforcement learning, it's a subset of ML only. So treat like AI is a big thing, and then you have machine learning, and within machine learning, you have deep learning, Gen AI, everything.
But
It's like
but in inverted commas, Bhavesh, in the language of Google or everything, ML is the subset of AI. But as I said, it's uh,
that.
together and not together. So it's
Mhm.
a thing which people can utilize as per their probably needs and preferences to solve the customer ends or satisfaction.
Mhm. Yeah.
Okay. So I hope, Bhavesh, you have an crisp answer of that particular question. So I'll move to the next question from Bhavika. What are the key challenges in deploying machine learning models in a production environment? So
Mhm.
that's
Okay. This is very interesting. Some key challenges you might face. See, if you want to build a scalable project, which is you want to use it for more customers, right? Then you have to plan the setup like that. Like you are using your one pipeline, but next time a new customer comes, you don't have to start from scratch. So in that case, operationalizing those kind of projects, you need to think about multi-tenant kind of architectures where you make sure for each customer you have one pipeline running. In general, when we talk about ML ops, right, you need to be mindful that if you are doing data gathering, the output of one file becomes the input of next. It should be modular. Okay, so that helps in your pipelining. If the data gathering output is the input for your data engineering, at the end of your data engineering, if you have the input data ready for modeling, then that becomes the input for your modeling. So keep your data structured: one file for data gathering, one file for data engineering, one for training, one for output, model outputs or report creation, whatever you want to do. And then when you try to automate it, it will become easier for you. Another idea here is, don't try to put all your variables and functions in the same file. Create some generic files where you have, yeah, it's also called your metadata. Create a metadata file where you have all your variables declared. So for another customer, you only have to change your metadata and all your scripts behave the same. Okay. Same way, you can create generic scripts for your functions that you are using. Data cleaning, some places, some date like fields, you might have to change it in every place somewhere. You can create some generic functions, place it in another file, just import it in your scripts, and then you can use it. So this way, if you keep it more modular, it will help you in operationalizing it quickly. Okay. Does that answer the question?
I hope that does. If not, then obviously you can just type in the chat box that if you feel something more is needed to be answered. So that quickly I'll move to the next question that I have from Ram. That Sagarika ma'am, I have a question that I've coming from a non-tech background and I don't have any tech experience. It's been almost 6-7 years I'm working in the industry, but I'm looking to upgrade something and do something exciting or better. But I have a question and confusion which is there in my mind from quite few time, that when I go ahead and try to look for the courses, there are data analytics courses, then there are machine learning courses, then there are institution providing entirely data science, ML and AI. So I'm confused that what is the step that I do take forward to, and is it necessary to learn all these three skills to be at a package of somewhere around that 20 or 30 or all the fancy packages that we are seeing or we are eyeing for?
Not at all. Nobody will expect you to know all of it. Okay. And I do understand it's confusing. But like I said in the first slide, if you know Python, okay, if you have the solid foundation, if you have revised your statistics a bit, probability basics of probability statistics and linear algebra might also, like, if you are understanding the maths, then for sure you want to know it. But even in linear algebra, matrix multiplication, matrix addition, we've done it at some point of time. It's a matter of revision. If you have these foundations, just start understanding what ML algorithms means. Try to do some use cases by yourself. You have so many Kaggle notebooks. You can download the data from there. Take the example of those notebooks. The essential thing is your problem solving approach. And if you don't have a tech background, I have people with me in nuclear physics background. Okay, they have background of journalists. They don't even have a tech background at all. And they are machine learning engineers, operations. They're doing everything. So it's not that you don't have a background. It's about adapting. And all these packages, right? Nobody will expect you. But if you know which use case, in which use case, which type of tech you can use, which algo gets applied where, then you have chat GPT and all integrated in Visual Studio Code, in Databricks, and AWS. You ask the chatbot which library to import and it will do that for you. So you won't have to do that. You need to know the right set of questions to ask it. But that's with problem solving, the right structured approach. I would
Correct.
suggest stick to basics. Don't complicate it.
Right. And moreover, just to add on to this, see, it's the only fear that stops 99% people or 99% specifically Indians to take that one risk which can change the entire course of their career, profession, or let's say even in their life. So see, this is kind of which I believe it's been almost 10 years. I'm also associated with data science and ML. So I believe and I've seen that uh, people coming from even BA background, which is normal BA history or BA political sciences, are even doing wonders in this kind of industries because they have actually nurtured themselves with the skill sets and tools which right now is demand or right now is being asked by the market or by the companies which is there. So it is probably gonna be a way where, in layman, I would like to explain this to you. For example, a person coming from a tech background, or a tech freak, or a person having a very good knowledge into maths would probably take 1 hour to grasp a particular skill set. You coming from a non-tech background would probably take that 2 hours or 2.5 hours or 3 hours to grasp those things. That is the only difference that you're gonna have, my friend. It's nothing which is impossible. And with so many platforms, the digital India has given you guys so much of atmosphere of learning anything from anywhere, keeping your work continued and then learning new skills. Obviously that can help you to adapt those things in a much more better manner, wherein you can give even 3 hours, 4 hours on a daily basis. Obviously I'm not going to put it in a way where it's going to be a very easy situation for you, but obviously if you're ready to turn the tables around for yourself, and if you really want to back those fancy packages which you're seeing in the market, then you would have to keep that mindset which can help you to transform yourself in this industry. So it is a very much eligible. People are doing it, and you can also do so. Just buckle your sock, pull up your socks, buckle yourself up, and make sure that you put in your best efforts. And in the end, just to answer the second part of your question, why there is data science, ML, and AI courses available, why not a simple technique? Because see, once you learn the complete packages of this industry, which is one set is data science, which is a kind of thing which gives you the analysis of data, and then comes the machine learning, wherein in layman I'm explaining this to you, wherein you input that data in those models, in those blocks, so that some prediction can come out of it when you structure the data and get the filter out of it. So once you're able to do it, the third part is that AI, wherein we bring that human intelligence to make sure that we are giving those predictions as close as to human minds, which is actually leading to more success rates. So once you learn all these techniques, you become a full package wherein the door gets open for you in multiple streams. It's not going to be restricted only to the, let's say, non-tech part of this, wherein you're only creating dashboards, or you're only helping the people to take business decisions. You'll be having the skill sets of actually building in the models as well, or checking with the teams who are working in the tech spec of it. And also you'll be able to give those predictions basis of generative AI and using those regressions into this. So if you develop yourself with all the factors which is there, then probably there would not be a single door that would be open to you. You'll have 10, 12 doors in front of you, and you can back the best of it. So think it in a way wherein learning things would obviously give you a better return of it. I hope, Sagrika, I've concluded it in
Absolutely,
the same
absolutely,
way.
absolutely, totally. Right.
Perfect, perfect. So I'll move to the next question. That I am Rameshwari, and I have skill sets of data analysis. I've been stuck on this data analysis part from 3 to 6 months. Is learning machine learning and AI and learning more to a tech aspect of it will affect my career and will be able to give me more fuel for next 5, 6 years?
Done the hard part. If you are able to do data analysis, if you can data engineer your data pretty easily in Python, then actually applying machine learning algorithms is actually a hit and trial kind of approach, right? You might have five algorithms that can work in your case. You have to try them, the five, you can analyze the results. That's the cool part, actually. That's the fun stuff. And I know we get the least amount of time for that. So actually, I'm missing out on the fun stuff now. You've done the hard work already. So, and why 5, 6 years down the line? Because now after you've done this, you can try machine learning, right, on your analyzed data. Now you try to see your results. And of course, 5 to 6 years down the line, why not, right? If you're working for a particular company, you are getting bored with the type of work or data, you can switch to any company you like, where you like the domain. Like the skill is not a problem for you here. Where you want to work, it's all up to you. And that's what is the coolest thing about this field, guys. Like if you get bored from one domain, I'm tired from retail, I want to go to defense or like aircrafts, right? You can take any domain, you can apply in any company. So that opens the doors for you. But data science application after data analysis should not be difficult. It's a matter of practice and knowing the models, of course, which to use when.
Perfect. So I'll pick just one or two questions that are left. So, hi Sagrika, this is Ayush. I have a question that Do you still think that being an Indian and working in the Indian market, learning this data science and ML techniques can give me a better career opportunity? Because I'm already doing 12 lakhs per annum, but that is completely in a non-tech marketing and sales domain. But it's been almost 8 years that I'm working and I'm in this package. So I've been hearing about this data science, AI and ML from a lot of peers, a lot of colleagues. So you being from this industry, would like to ask you this question, that whether going ahead and learning this can actually boost something better in this, or I should stick to whatever I'm doing at this particular kind of career situation that I'm into.
See, the roadmap for data science is like if you are becoming a data scientist in the first place, right? The scope right now, the market trend for next 5 to 6 years, it's not going anywhere. It's there to stay. Within the next 2 years, the change that you'll see is people from data science roles who have done data science, now they're trying to go into AI engineers, ML engineers kind of role. That after data science, now you understand the ML ops part of it, operations part of it. You can always switch roles also. Okay, that happens a lot. With that, what happens is you kind of become a full stack data scientist because you gather the data, you can data engineer it, you have become a data scientist, you can operationalize it. What's the next step? You can become AI managers, product managers, and I think this is the field that's going to grow after next 5 years, where you will have all AI based products and a ton of it. And especially like I said, these IoT devices, they are becoming so close to us, like our smartwatches and everything is AI empowered. So data products and AI managers, engineers, next 5 years. If these 4 5 years you work in this regard, you can get very high paying jobs in these roles in the future, right?
Right, right. It's well articulated. And also to answer this, Ayush, you know that it took you 8 years to grab a package of 12 lakh, wherein still you are not happy with that situation and you still want to go ahead and do it. So when you hear it from here, when your heart is saying that you have to go ahead and work for something more big in the market. So yes, data science, AI and ML is the future, and it's the technologies which is latestly being adapted by Indian market. It was there from last 50 years, but people were not aware about these techniques. People was not adapting these techniques and not utilizing it for their benefits. Even in India, if I remember, in the year of 2014 15, 30-40% of people were aware about it. Then slowly, gradually, when the COVID phase hit down to us during the time of 2018 till 2020, that was the time when it rose from here to here, when companies started to understand and how these techniques can be life saviors and how big and lucrative career options are this. So obviously, coming from a background of 8 years, coming from sales and marketing, obviously you have your own skill sets that you can utilize. When you add on those skill sets with this data science and ML and all this tech part of it, so you'll be able to handle client dealings more better than a person who is only having knowledge into that data science or ML or AI techniques. So you can obviously, after learning this course, present to recruiter as a better package altogether, that I know how to do sales, I know how to do marketing, I can handle multiple parts of it, I know how to do negotiate, I know how to do handle team. Because being a data scientist, when you elevate in your career, there would be certain teams which will be working under you. So you having that exposure of 8 years in directly managing teams and directly handling those verticals can obviously give you an upper hand among your peers which are going to be there at the same kind of packages that you're going to be into. And that is how you can probably eye for easily somewhere around a good hike or a decent hike. Obviously, in the end, the ball is in your court. You will be the person sitting in front of that chair of the recruiter. So if you really develop these skill sets well, then yes, pay getting a good average package above anything which is the decent hike of 2025 is certainly possible. But obviously, in the end, I would conclude that it is you, it is every one of you guys who are there in the game. You guys need to give your best. We can only act as a, let's say, a bridge between you and that room wherein the recruiter would be sitting, and there would be 5 forms of packages starting from 5 lakh to 50 lakhs per annum. You need to decide which is the ball that you want to hit in. So there are everything possible in this sector. It is a sector with full of hopes, with full of packages, with full of learnings, with full of exposures. When we talk about companies like product based, services based, or the startups, those three companies have a different set of acceptability when it comes to the techniques and the people that are coming from a background of. So yes, multiple opportunities are there. You just need to learn yourself and dwell yourself in these techniques, and definitely you can expect something better in terms of learning, in terms of your career development also, and also in terms of monetary benefits that you can avail from this. So I hope, Ayush, we both have answered that in a much more clear manner so that you can take your decision wisely and carefully. It's about your career. So I guess we are done with the question, guys. I'll wait for another 2 minutes. If you have any more questions, you can please type in the chat box. We'll be definitely answering that for you. I guess I have a question from Nirnay. Hi, Sagrika. With the programming languages evolving, especially SQL, how do we keep ourselves updated with new concepts apart from subscribing to the online newsletter? Would this affect the data analytics and scientists in the long run?
So, see, if, like I said, if you know SQL, right, you can, if there's a different new technology coming for databases, if you know how to use SQL, you can easily adapt. That is what continuous learning means. In the future, what's going to happen is this is all kind of going to get automated. What you need to know is the base concept, how SQL works. At the end, if it gets automated, you will be the one who will using that automated product too. You get it? So beside, and what newsletters do for you, they will tell you, okay, with, for example, Snowflake, that's what we use for SQL a lot of times, or Oracle. With new newsletters, what you will get to know? You will get to know, oh, this is new technology where database stuff can be automated. But behind the screens, they will still be using SQL or some of these technologies as well. So if you know one database technology, you are good. If you know one programming language, you are good. So that's what it means. Like if you can code in Python, you can code in JavaScript also, because you will declare variables, you will call some functions, process stays the same. What will happen in the future is this stuff will get automated, but it will not be a black box for you because you know how they automated it, right? They're doing this with front end now. Remember, we have all these websites and all, people, full stack developers used to start from scratch. Now you have Shopify and all where it's a drag drop based stuff. Behind the screens is HTML, CSS, right? But it's just automated. So newsletters, new updates will help you keep updated. Same technology, where is it going now? How is it getting used now? It'll be more applications actually. The concept still say the same.
Perfect. I hope, Nirnay, that answer your question. Nirnay, I have one more thing to go ahead and ask, which is also very interesting. And I even discussed this somewhere in some webinar, that I, Sagrika, with the advancement of new programming languages like R, how would it take a programming language like Python to lose its significance?
It's not going anywhere, at least for the next 10 years. Like
100%.
at least, or nowhere close. Like I've not seen a technology right now competing with Python. So I don't think
Correct.
it's going to happen. What will happen, like I mentioned above, is like your the code that you do will become more automated. There'll be more applications which will generate the Python code and give it to you, which is already happening today. You know that. So Python is again not going to go away. I don't think Python is going away anytime soon. There is PySpark, which is kind of a competitor of Python right now because of big data, which could take the lead in the future, again, because of the growing size of data these days, right? If you have less data, Python and R is fine, like I said. But if there are more complex problems in the future, then some additional technologies like PySpark and Databricks, if you know it's built on Spark, take. So they've already been ahead of time and seen what kind of problems people will face. They build Databricks on Spark behind the screen. So that's why it's good in big data. So if you follow latest updates, you'll see what these leading companies are doing, like kind of being smart about the future in that regard. But Python, at least for next 10 years, don't see it going anywhere.
Python has been a very dominant language in
Yeah.
the fields like specifically data science and ML. So it's only because of the established presence in the ecosystem and continuous updates that ensure that it will remain relevant for probably quite some time, as you mentioned, because of versatility, the community, the interoperability, the education and training. Even I was probably reading somewhere that there were rise in few languages like Julia and Rust, but even they have not replaced Python or even come close to that. It
Yeah,
is only because of that versatility and lucrative thing that Python have. So in short, it would not go anywhere soon. It's very long. So
exactly.
you can be sure of it, Nirnay. And that is why everyone is taking Python as their first priority. And other languages also have their impact, and everyone should learn if they have time. But obviously, comparatively to Python, nothing is there that is more important or relevant or being used in today's world. So I hope we have summed up with all the questions, I am sure. So thank you so much, everyone. Thank you so much, specifically Sagrika, for taking out precious time on this Wednesday evening. It was a pleasure having you on with us.
It was a nice experience, guys. You guys asked very nice questions. I'm glad you all are curious and excited for you guys to feel free to reach out to us for any questions you have in the future.
Definitely. Thank you so much, guys. Once again, I specifically thank all the learners and all the attendees. I hope this was a useful time for you guys that you have invested and you are taking back full of learnings. If anything persists, we are available anytime. You can reach out to us, and we would love to have Q&As with you guys. Thank you so much for joining in, guys. See you in
Thank
the
you.
next session. Bye bye. Take care. That's all from IIDST and Sagrika. Have a great day ahead. Bye bye. Take care.